This video will show you how to use the binomial and Poisson distribution functions in Excel to complete number 5 and number 6 in your Lab 2 assignment. So you'll see that these look pretty familiar. These are just like the examples that we covered in class. I'm going to show you how to use Microsoft Excel to do this instead of using the table in the back of your book. So Microsoft Excel doesn't require any raw data to calculate probabilities based on these two distributions. So we are just going to go ahead and work with the file that we worked with in the last section of the lab, so for all of these. And we're just going to create a new tab that's labeled Binomial and Poisson. So I'm just going to copy this, so highlight it, hit Control-C, and you can see that I already did it here, so you can just rename it and then hit Control-V. So there it is. All right, so let's go ahead and organize our work. So I'm just going to go ahead and copy and paste all these different probabilities that we're looking for into our workbook. So just highlight, Control-C, Control-V, highlight, Control-C, Control-V, highlight, Control-C, Control-V, and then finally my last one, copy it and paste it into Excel. All right. So something you can do as well to kind of keep track of everything. So we're going to tell Excel what is our p-value in the population, what is our number of trials, or in other words, our n, and what is our x value that we're interested in, or the number of successes. Now these all change, and I've already included those in Excel. But I can go ahead and just kind of make note that our p is 0.20, and for this case our n is 11. So I'm just going to put that in here. So p equals 0.20, n equals 11, just to keep track. We'll manually insert these in our functions. Okay, so the first one is the probability of an x value that equals 2. Or in other words, the probability that exactly 2 album sales would be digital if 20% of album sales in the population are digital and we have a sample of 11 albums. So we can just type equals, and I'm going to start to type binomial, but I'll see as I type that it pops up, so I'm just going to double click this here. And it gives you some hints as to what you need to insert into this function to get your probability. So the first thing, number s, that's the number of successes, or in other words, our x value. So that's 2 for this one, comma, space. How many trials? Well, there's 11 albums, so that's 11, comma, space. The probability of successes in the population, we found that to be 0.20. It's given to you, so 0.20, comma, space. And then here you tell Excel if you're looking for a cumulative probability or an exact probability. If it's a cumulative probability, you simply type true. If it's an exact probability, which this one is, exactly 2, you type in false, F-A-L-S-E. Close it with a bracket, hit enter, and that is the probability if we had a sample of 11 albums and the probability in the population of getting one that's digital is 0.20, then we would have a 0.295279 probability of having 2 albums in this sample that were digital. So that's how you can interpret that. So the next one is looking for probability of x less than 3. Well, remember, our only 2 options is an exact or a cumulative. So what cumulative probability would correspond to the probability of x less than 3? So think about that for just a second before I give you the answer. Remember, cumulative tells us the probability of x less than or equal to some value. So if we're looking for the probability of x less than 3, Well, then we can find the cumulative probability of 2, and that'll give us the exact same answer. Because if it's less than or equal to 2, well, then it's less than 3. So let's go ahead and do that. So equals, there it is. Double click it. The number of successes, remember, less than or equal to 2 will give us the probability less than 3. So 2 is what we're interested in, comma, space. We still have 11 trials, comma, space. The probability in the population is still 0.20, comma, space. Now we actually do want the cumulative probability, less than or equal to 2, because we're looking for less than 3. So we'll type true in here, another bracket or parenthesis, hit equal, and there we go. Okay, so now let's figure out the probability that less than 5 album sales will be digital. Well, this one's pretty straightforward because it is a cumulative probability to begin with. So we can just type equals BINOM, binomial distribution pops up, double click it. The number of successes that we are interested in, 5. We still have 11 trials. The probability in the population is still 0.20. And we do want a cumulative distribution, or cumulative probability, less than or equal to 5, so we'll type in true, and there we go. Now for this one, if it's greater than 5, well, this is the complement to less than or equal to 5, because this is saying the probability that 6 or more album sales will be digital, whereas this is the probability of 5 or less. So we can simply just do the complement rule here. So you can put equals to tell Excel that you're getting ready to type in a formula. 1 minus that probability there, hit equal, and there you go. Okay, now let's move on to the questions for the Poisson distribution. So here's our lab assignment. And now we are looking at the number of calls in a call center or a customer support center. Now remember, this is our lambda, the average phone calls in this specific period of time. And for these first two, the time frame is the same as the time frame used to calculate this average. But you need to keep in mind for part C and part D that now we're going to have a different lambda t, or a different average for this specific time frame. So because we have 1.5 every 5 minutes, well, 10 minutes represents 2 5 minutes, and 2 times 1.5 is 3, so we need to keep that average in mind for part C and D. Well, first, let's go ahead and insert the probabilities that we're interested in into the Excel workbook, just to keep organized. So I'm just highlighting, Control C, and then Control V to paste. Just to keep organized and to make it easier for me to grade your Excel workbook. All right, there we go. So just like before, let's go ahead and record the important bits of information. So first, let's go ahead and say, okay, well, lambda equals 1.5 phone calls every 5 minutes. So this is the important bit of information for these first two, that the average is 1.5. So average equals 1.5. That's our lambda. And let's see, is there any other important information? I don't think so. Let's find out. Let's go in here. Okay. So to do the Poisson distribution probabilities, you can type in equals POI, and it pops up. Just double click it. Our x value in this case is 0. Our mean, or our average, or our lambda t is 1.5. And then this has the same meaning as this did here. So if we want the cumulative probability, so x less than or equal to something, we would say true. If we want the exact probability, we say false. For this, we want exactly 0, so let's say false. Parentheses, enter, and there we go. This next one, we're looking for the probability of x greater than or equal to 3. Our average is still 1.5 because we're still looking at 5 minutes time. So for this one, we can kind of work backwards. So x greater than or equal to 3, well, if we find the complement to that, we can take 1, subtract it, and figure it out. Now for this one, x greater than or equal to 3 includes 3. So we would want to find x less than or equal to 2 to then use the complement rule. So let's go ahead and find that. So equals, there's the Poisson distribution, double click it. X is now 2. The mean is still 1.5. And we want the cumulative probability, so true. We want to find x less than or equal to 2 to start. Close it with the parenthesis, hit enter. So this tells us that the probability that 2 or less or 2 or fewer calls arriving in the next 5 minutes is 0.808847. But we want to know the probability of 3 or more. So to find that, we can take 1 minus the probability of 2 or less. Oops. So put it equals first. Tell Excel that we're getting ready to do a function or some math. And click on that. Equals, and there you go. Okay, the next one, px equals 3. So that's going to be a false when we get to the cumulative part. But remember, now we've changed our time frame. So we need to take 5 minutes. There's 2 of those here. So 10 minutes equals 2 5 minutes, 2 of the original time frame for the average. So 2 of those multiplied by the original average, and we get 3. So I'm just going to remind myself now that now my average equals 3, just so that I don't forget. Okay, so same as before, equals POI. There it pops up. Double click it. Our x value is now 3. Our mean is also 3. And we do not want the cumulative probability. We want the exact, so we'll type false. Close it with another parenthesis. Hit enter. And that is the probability that we would get 3 calls during the next 10 minutes based on the average for 5 minutes. Okay. Now this one's pretty straightforward. It's just a simple cumulative probability, but now we have our new average. So we can just type in equals, POI, pops up, double click it. 2 is our x value. Our mean or average or lambda t is 3. And we do want the cumulative probability, so we'll just type in true. T-R-U-E. Close it in a parenthesis, hit enter, and now we have that value.